So today we're going to be talking about mass to mass problems. So we've done mole to mole conversions, and this is the format that we use. The given in moles times the mole ratio gives us our answer in moles. Then we go to mole mass conversions, which is where the given is in moles. We multiply by the mole ratio, the molar mass of the unknown gives us our answer in grams. Then the mass mole conversion, same thing, just kind of mixed up a little bit. So the given in grams, the molar mass of the given, and then the mole ratio gives us our answer in moles. And so today we're going to talk about mass to mass conversions. So you're going to be given a quantity in grams. You're going to multiply that by its molar mass. Then you're going to bridge the gap with the mole ratio, and then finally do the molar mass of the unknown to get your answer in grams. See, obviously this one's a little bit longer because you're going to take your given and multiply it by 3 different factors. This is why it's been so important that we write down our units and that we make a point to write down what our given is and what our own unknown would be. So what we're going to do is we're going to go on over to your packet, and we're going to look at page 12. So find page 12. It looks like this. And what we're going to do is we're going to work a couple of these problems. So my plan is to work problem 1A and B so that you kind of get an idea of what the format looks like. And then you can go on to work the rest of these problems. So let's, you're going to need your calculator, pen, pencil, something to write with, and your periodic table. So let's go ahead and look at this very first problem, 1A. So before I get started, I'm going to go ahead and write down the equation so that way I'll have it handy to use. So 4FeCr2O7 plus 8K2CO3 plus O2 yields 2. Fe2O3 plus 8K2CrO4 plus 8CO2. Almost ran out of room. Okay, so looking at problem, this is page 12, 1A. It says how many grams of FeCr2O7, so this is our unknown, how many grams are required to produce 44.0 grams of CO2. So this is my unknown in grams, and this is my given in grams. So I'm doing a gram to gram problem, which would be mass to mass. So I'm going to follow this little skeleton right here to help me work this problem. So the first thing that we have to do is we have to write down our given in grams. So 44.0 grams of CO2. Then the step 2 is the molar mass of the given. So just write down here, we have 1C, so that's 1 times 12.01, 2O, 2 times 16. So we have 44.01, and that's of course grams per mole. So I'm going to put this in with the 44.01 grams of CO2 on the bottom, 1 mole of CO2 on the top. So now grams cancel out. So we've done our given in grams, we've done our molar mass of our given. Now we're going to do the mole ratio. And remember, the mole ratio is the given to the unknown. So I'm going to put my 8 moles of CO2 on the bottom so that I can cancel out this mole of CO2. So that means 4 moles of FeCr2O7 goes on top. So back to our skeleton, given in grams, molar mass of the given, mole ratio. Now we've got to do the molar mass of this unknown, okay? So that's 1 iron, so that's 1 times 55.93 Then that's 2 chromiums. So 2 times 52. And then we have 7 oxygens. So that's 7 times 16, which is 112. And this is 104. So I'm going to add all those up. And I get 271.93 grams per mole. And I'm going to run that through just one more time just to make sure. Yep. Okay, so now I'm going to plug this in. And I want to get mole on the bottom to get rid of this mole. So 1 mole of FeCr2O7 on the bottom. And then that puts 271.93 grams of FeCr2O7 on the top. And that cancels out. So now we have to run it through our calculator. So to do that, we're going to say 44 times 1 times 4 times 271.93 equals divided by 44.01 equal divided by 8 equal, and then divided by 1 equal. And I get 136 grams of FeCr2O7. And it's 3 sig figs and 3 sig figs. Okay, same thing we've been doing is just taking it one step further. So let's go on and do B together. So you'll have one more practice problem that you can refer back to. So if we look at B, it's the same chemical reaction. So I'm going to go ahead and write that down so that I have it to refer to. Okay. So for number 1B, it says how many grams of O2 are required to produce 100.0 grams of Fe2O3. So there is my given and my unknown. So back to my skeleton, I'm going to start with my 100.0 grams of Fe2O3. And then I'm going to do the molar mass of my given. So that's 2 iron, 55.93. And then that's 3 oxygens. So 2 times 55.93 is 111.86. 3 times 16 is 48. I'm going to add those together. And I get 159.86. So now remember, you don't have to necessarily show this. If you want to work it in your calculator, that's fine. Just remember, it's kind of hard for me to go in and help you if I don't know exactly where you messed up. So anyways, but that's totally up to you. So that's grams per mole. So I'm going to go put this in, and grams are going to go on bottom. And 1 mole of Fe2O3 goes on top. So grams cancel out. So now we go to our mole ratio between the given and the unknown. So 2 moles of Fe2O3 go on bottom, and 1 mole of O2 goes on top. Right there. So our last thing is to find the molar mass of the unknown. So in 1 mole of O2, and we know oxygen 16, so 2 times 16 is 32. There's 32 grams of O2. Now moles will cancel out, and now we just run it through our calculator. We say 100 times 1 times 1 times 32 equals, divided by 159.86 equals, divided by 2 equals, and we have 4 significant figures, so that would be 10.01 grams of O2. I'm going to run it through just one more time. Yep, and that's our answer. Okay, so once again, if you kind of follow these little skeletons that I've made for you, this will help you to kind of see where you are in your problem. And the more problems you work, the more familiar you'll become with this, and the less you'll have to refer back to it. But if you have any questions, please let me know, and I'll be glad to answer them. Talk to you later.